Hello everyone, in this video we're going to talk about angle relationships, specifically two relationships with vertical angles and angle bisectors. Okay, so let's talk about vertical angles first because it's pretty simple. Alright, usually when you see a picture where there's some sort of X like this, we're going to have vertical angles. Now, if you watched the previous video on supplementary angles, you know that these two angles have to add up to 180. They're supplementary. So let's say, for instance, that this is 80 degrees and this is 100 degrees. Okay? By using our vertical angles, what vertical angles tell us is that when I have an X like this, right, or the idea of I see maybe an X in a diagram or something, that this angle right here and this angle right here are vertical angles. And these angles are congruent. So if this is 80 degrees, this is also 80 degrees. And if this is 100 degrees, so this one is 100 degrees, then this one is also 100 degrees. So that's this idea behind vertical angles. We just set them equal to each other. Now, can I do that if I have variables and unknowns? Sure. So let's look at another example. So I have something that looks like this. And we can see that I'm probably going to have some vertical angles right here. So let's say that this angle right here is 120 degrees. And this angle is 4x plus 40. And let's say that this angle over here is 2y plus 10. I'm using different letters for a reason. Let's say that this problem I want to try and solve x and I want to solve y. I can do either one in either order, but since I'm talking about vertical angles, I'll start with this. If I have vertical angles right here, I want to set these angles equal to each other. So I'm going to get 4x plus 40 equals 120. I'm going to solve this because they're equal. Minus 40 minus 40. 4x equals 80. I divide 4, and I get x equals 20. There we go. I found out what x is. Now, I bring this back because you see a lot of problems like this. This 20, this is going to work out where this is 120 degrees anyway, so that doesn't help me with 2y plus 10 at all. This I know has to add up to 180 because these two angles are supplementary. Okay? So I'm going to have for this one 120 equals 2y plus 10 minus 10 minus 10. 110 equals 2y, divide 2, y equals 55. So I found x, I found y. I had vertical angles to find x. With y, I used supplementary, but I did it anyways. So now let's talk about angle bisectors. So if I have angle bisectors, what that means is, let's start with an example. So let's start with just a picture like this, an angle. And let's say that this is A and B and C. And let's say that this is D. So BD is an angle bisector. If BD is an angle bisector, it means that these two things are cut perfectly in half. So if this is 30 degrees, this is 30 degrees. If this is 50 degrees, this is 50 degrees. So let's say, for instance, that ABD is 80 degrees. See, this is just going into here. I just can't really make it nicely, but that's 80 degrees. Let's say DBC is 2x plus 40. If I am now working with angle bisectors, what I'm going to do is set these equal. So with angle bisectors, you set them equal. 2x plus 40 equals, angle bisector is 80. So I minus 40, I get 2x equals 40, divide 2, x equals 20. So I was able to solve x. I could also find ABC, the whole thing. If I know this part is 80, well, I don't even need to solve this. If I know this part is 80, then this part also has to equal 80, so the whole thing is going to be 160 anyways. Not a really lifelike example because this looks like an acute angle anyways when I add up to 160. But I just wanted to solve for x. Remember, in geometry, the picture doesn't always have to match the math, so you have to be a little careful there. But we've done vertical angles, we've done angle bisectors. Hopefully this example helps you and makes a little bit of sense.